Hello, this is chapter 2, part 2. We're going to continue on with ionic and ionic compounds. If you recall from chapter 2, part 1, we spoke about periods, groups, meaning we go across the periodic table in the row, groups or columns going up and down. We spoke about isotopes, how an isotope has the same number of protons but different number of neutrons. We spoke about the atomic number, which gives us the amount of protons, and the mass number, which is the addition of neutrons and protons. Empirical formula, molecular formula. Empirical formula is the more simple whole number. For instance, H2O2 is the molecular formula. HO would be the empirical formula from last class. So we're going to continue on. Molecular compounds, usually composed of nonmetals. You recall nonmetals are located on the right side of the periodic table, versus ionic compounds, where you transfer electrons from one atom to another, usually a metal combining with a nonmetal. And we'll speak about this next topic of the octet rule later on, where we want the valence electrons, the electrons on the outer shell, to have 8 electrons. Octet, same thing as octagon, octopus, meaning 8. And there's some exceptions, of course. Hydrogen and helium, they prefer to have 2 electrons on the outer shell. We also have some exceptions in the transition metal. Recall transition metals are located in the middle of the periodic table. And we have some exceptions where you have more or less than 8 electrons as well. So we have here sodium chloride, a metal. Sodium, group 1, if you recall, is an alkali metal. And chlorine, which is group 7, is a halogen. So in this case, when a metal and a nonmetal come together, the metal will donate one of its electrons to the nonmetal. NaCl, we have 11 protons for sodium in purple here, which means we have an atomic number of 11. It will donate one of its electrons to the chlorine. Chlorine has 17 protons and 17 electrons. And hopefully in the next diagram, yes, we'll see here the neutral atom. It says here the neutral atom contains 11 protons and 11 electrons, and it will donate one of its electrons to the chlorine. And how do we do this? If we were to have the sodium, I'll draw right here, it has 2 electrons in the first shell, 2 electrons, that stands for electrons, and then in the next shell it has 8 electrons. I'm not going to draw all the electrons, but there's 8 electrons in the next shell, and in the last shell it has 1 electron. Okay, how do we know this? We said earlier the nucleus of sodium has 11 protons, therefore it has 11 electrons. We have 2 in the first shell, 8 in the next shell, and then 1 in the outer shell to make 11 electrons. Conversely, we have here the chlorine. Maybe I'll draw over here the chlorine. It has 17 protons, therefore 17 electrons. Again, the first level has 2. We'll talk about this in chapter 6, but the first level has 2, the next one has 8, and the last one will have 7 electrons to give a total of 17. So as I said, the electron, change the color, the electron on the outer shell will donate its electron to the outer shell here of the chlorine. And now we have a nice relationship here where now the outer shell of sodium will have 8 electrons. And how many will the chlorine have? It will also have 8 because one of the electrons has transferred over, and now this will become 8 electrons. So when the sodium gives up its electron, and now it has more protons than electrons, it is called a cation. And the chlorine here, now that it has received 1 electron from the sodium, it has more electrons than protons. It has 18 electrons and 17 protons. It has 18 negative charges and 17 positive charges. Therefore, overall, we have a -1 charge. And we call this an anion. So cation when you have a positive charge, and anion when you have a negative charge. So as it says here, as sodium loses an electron, it becomes still has 11 protons. If you had 12 protons, it wouldn't be called sodium anymore. Remember, the protons defines the element. And as we said, when sodium and chlorine come together, the sodium will donate one of its electrons to the chlorine, and it will become positive because we have 11 protons and we have only 10 electrons left. And you guys recall, electrons are negatively charged, protons are positively charged, therefore overall we have a +1 charge. Another example of MgCl. Mg is a alkaline earth metal from group 2. Chlorine again is a halogen. So we look here in the diagram below. Magnesium has 12 protons. So again, 2 of those electrons, if it has 12 protons, it also has 12 electrons because we want it to be neutral. 2 of those electrons will go in the first level, 8 will go in the next level, and then you'll have 2 electrons sitting on the outer level. Conversely, if you remember from chlorine, chlorine has 17 protons. It has 2 in the first level, then 8, and then 7 on the outer shell. So the relationship here is that the magnesium will donate 2 of its electrons. One will go to one of the chlorines, another one will go to the other chlorine, and you will see that magnesium, since it loses its 2 electrons, it will now have 8 electrons on the next shell, and chlorine will each receive 1 electron, so each chlorine will have 8 electrons to be happy. When magnesium loses 2 electrons and gives to the chlorine, it becomes Mg2+, and when chlorine receives an electron, 1 electron, it will be Cl-. There's 2 of them. You can see here there's 2 chlorines, 1, 2. Therefore, it will become MgCl2, and we'll talk about that in the next few slides. Just a little bit of summary. Here's what I've just been speaking. The ionic compounds must have a net charge of 0. So when you start off, you have sodium has 11 protons and therefore 11 electrons to give a neutral of 0. The 2 examples I showed, Na plus and Cl minus coming together to give NaCl, and Mg2 plus and 2 Cl minuses. If you look at this, Mg2 plus and 2 Cl minuses, so 2 plus and 2 minus, because there's 2 of them, will give MgCl2, which is again neutral. Neutral on the left, neutral on the right. So luckily, we will all have the periodic table in front of us, but we can figure out what are the charges of a particular element. So for our alkali metals, which is group 1, all of them will have a charge of +1. Notice here they're all +1. The alkaline earth metals will have +2. This aluminum here will have a +3. And on the nonmetals, they are negative charges because they receive the electron from the metals. Here, you have halogens. They will all be negatively charged, -1. Our chalcogens will be -2. They like to receive 2 electrons to be happy. And noble gases, they are very stable. They don't receive or give electrons. And if you ask about the transition metals, there's no trend in the transition metals in terms of what their charges are. So naming inorganic compounds. Inorganic compounds, you can just say, are those that are opposite of organic for now. Organic compounds contain carbon or hydrogen atoms. Inorganic compounds are opposite. I mean, there are some exceptions to inorganic compounds. For instance, CO2, it does contain carbon, but it's an inorganic compound. But we'll focus on naming. So when we talk about ionic compounds, recall ionic compound is a metal combining with a nonmetal. We will use the crisscross method. There's other methods to write formulas or name compounds in the textbook, but I think this is probably the most straightforward in my opinion. We write the metal name first and then followed by the nonmetal ion. So for instance, sodium chloride. Sodium is the metal, you write that first, and then chloride. It's not sodium chlorine, but we'll talk later that the nonmetal becomes ide. And to figure out the charges, we use this crisscross method, which I'll show you in a few minutes. So the crisscross method. If I were to ask you if we were to combine calcium and bromine together, calcium is an alkaline earth metal, bromine is a halogen. We know the charge state for the calcium is 2+. The bromine is 1-. And if we look down here in the middle, we simply crisscross the 2. The 2+ comes down. It comes down to the bottom right. The bromine, -1, comes down to become the 1 subscript for the calcium. And we're left with Ca1Br2, or simply write CaBr2. If there is ever a 1 in the subscript, we usually ignore this 1. Just like if we had, I'm going to do an example up here, Na+, Cl-, we crisscross. We don't say sodium 1. We don't write Na1Cl1. We just say NaCl. So this is a no. So what about if we have a 2+ for our magnesium, we have a 2- for our oxygen. So again, we crisscross. We see the 2+ and the 2-, they crisscross, and you get this Mg2O2. So one additional rule I need to add is we need to simplify everything. So if you had Mg2O2, this reduces to MgO. You divide both the Mg and O by 2, you get MgO. So let's give this a try. We have here, I'll give you guys a few minutes so you can pause the video. What would happen if these two elements came together? In the case of, I'll do the first one, potassium. is a plus, chlorine is a minus. You crisscross. Again, I'm getting this information of K being a plus and Cl being a minus from our periodic table above. And this comes out to KCl. Again, I'm going to put these answers on Blackboard for you in another file so that you can use that as a reference. I want you guys to try on your own first. And if not, you can always look at the bottom right-hand corner to give you the answer key, but not the step-by-step work. So if we did magnesium, I'll go straight to D, Mg2+, magnesium being an alkaline earth metal, sulfur, a chalcogen, 2-, we crisscross, it becomes Mg2S2, and then it becomes MgS. We need to simplify. Okay. Any questions? Ask your SEC 201 lab instructor or lecture instructor. When we're naming compounds, the metal will maintain its name, just like sodium chloride. The sodium will maintain, the metal will maintain its name. The non-metal will now become, it'll go from ene to ide. I'll repeat, going from ene to ide. Recall, anions are the non-metals and cations are the metals. Cations get a positive charge, anions get a negative charge. So here we see all of the non-metals, they become ides. Sodium chloride, magnesium fluoride, potassium nitride, making up compounds as I go, but you get the idea. So in this case, we're going to ask you to name the following compounds. So you can just pause the video and give it a try. I'll do the first one. Potassium here is K. Potassium, and it's not potassium chlorine, it becomes potassium chloride. If you guys do a student evaluation for me, you can say Dr. Mark's writing is not too clear. Anyways, potassium chloride. So definitely on your exams, you're going to have to either name a compound or write the chemical formula based on its name. And a lot of times I tell my students, instead of, if you want to check your answer, you should always go backwards. So for instance, if I ask the class, what is 1 plus 2? To check if 1 plus 2 is equal to 3, you don't say take out the calculator to check. You would try 3 minus 1 to see if you got 2. So when you're naming compounds, always, for instance, if the question was name the following compound, you would write potassium chloride. And instead of going over and over again, KCl, does it equal potassium chloride? I would simply just, on the exam, just cover the question. So I'm trying to cover the question now. And try to go backwards. You wrote potassium chloride, see if you can write the chemical name, and hopefully you get the original question back, KCl. So again, some more examples of write the chemical compound. So we're going the opposite way. You can pause and give it a try. Cesium oxide, cesium is CS. If you recall, it's an alkali metal, alkaline metal. Therefore, it will have a charge of +1. And oxide, which is here, it has 8 protons. It will be 2-. And you will crisscross to give CS2. O. Again, you don't put the 1 there beside the O. It will become CS2O. I spoke a little bit about transition metals, but they have a special case in that a lot of them have 2 possible charges. So for copper, you can call it copper 1, copper +1. Before they used to use the nomenclature, which means the naming, that's cuprous ion. And for copper 2, Roman numeral 2, you say cupric ion. For iron, you have iron 2, iron 3. So those of you familiar with Roman numerals, your Rocky movies, your Friday the 13th movies, 1, 2, Rocky 3, 4, 5. Unless you're from Asia, then you will write 1, 2, 3, and we won't get into 4, but just let me not confuse you and erase this. Anyways, these are our Roman numerals here in the middle. So yes, transition metals again located in the middle of the periodic table. So unfortunately, we have to memorize about 10 of them. So we have here chromium, manganese, iron, cobalt, nickel, copper, gold, mercury, tin, lead. Okay, so these, I think 1, 2, 3, 4, 6, 10 of them have 2 possible charges which we have to memorize. There are 3 cases that are transition metals: silver, cadmium, zinc. Those 3 do not have more than 1 charge. So we can, one mnemonic I tell my students, silver CDs are made of zinc. So if you can remember that sentence, silver CDs are made of zinc. These are the only 3 in our class where you only have 1 charge, and that becomes important later, as I'll show you. So how do we write the formula for a compound that contains a transition metal? Let's look at the case here. Iron 3 chloride. Iron is a +3. Chloride is a -1. You crisscross to give FeCl3. So the 3 here in the question will tell you its charge. As I said here, there are 3 examples or 3 cases where you only have 1 charge: zinc, cadmium, and and silver. So we say silver CDs are made of zinc. If you can remember that, that will help us in naming these particular compounds. So you don't have to read this, but if you just follow, you again look at the Roman numeral for the transition metal, and then you crisscross. The ending will be an "ide" again for the non-metal. So if we just go straight to the example, name the compound FeSS, that'll be iron and sulfide. So you ask, well, what's going to be the charge for the iron? Is it going to be +2 or +3? We know sulfur is 2-. If we have Fe here, it can either be +2 or +3. We know, this is the key, we know it has to be +2 because when we uncross the FeS, if we uncross it, S is always going to be 2-. And therefore, iron has to be 2+ for it to simplify into FeS. So if Fe is 2+, S is 2-, when we uncross them, we come up with iron 2 sulfide as its name. Here are some examples to try. Again, you pause the video. I'll do one example here. In this case, we'll do C. Zinc is, as this is the name, as I said earlier, because zinc is one of our 3 silver CDs are made of zinc, where it only has 1 charge, we do not write zinc 2 because it only has 1 possibility. So we don't write this. Let's erase. We have zinc, and then the fluorine becomes fluoride. This will become zinc fluoride. At the bottom, write the chemical compound. Let's try the first one. Copper Cu for copper will be copper 1. We have to write the bracket. Copper 1 oxide, you're right. So Cu is, in this case, will be 2+. I'm sorry, Cu will be +1. So let me erase this. Cu will be +1, coming from the name copper 1. And the O will be O2-. It's a chalcogen located here. It'll always be 2-. You crisscross and you get Cu2O. So we continue on with polyatomic ions. Poly meaning many. Atoms, we know what atom is, hopefully. And ion is something that has a charge. So cation is a positive charge, anion is a negative charge. So if we put it together, we have poly, many atoms together to give a charge. So here's a table which we need to be familiar with. I don't like to say memorize, but we do need to be familiar with through practice. All of these have multiple. All of these are multiple elements, and they have a charge. And if we look here, about 90%, 95% of them have oxygen involved. So the most common ones here are in bold. Okay. And if we know these common ones, we can find its corresponding name for that when we lose an oxygen. For instance, if we have nitrate, if we know nitrate is NO3-, nitrite is simply the same charge, except we lose 1 oxygen. So nitrate is NO3-. We lose 1 electron or lose 1 oxygen, it becomes NO2 minus. So through practice, you'll become very familiar with this. Let me see if I can explain one mnemonic for you. Okay, so if we go back, if I give you one mnemonic, just follow me. If we can remember Nick, the camel, eats a clam for supper. In Phoenix. If we focus on the word Nic, this stands for nitrate. I didn't say this before, but all the 8s are the most common ones. Nitrate, carbonate, chlorate, sulfate, phosphate. If we look here, how many consonants in the word Nic? 1, 2, 3 consonants. So we say NO3. And how many vowels? 1 vowel. So it's NO3 minus for nitrate. For camel, which is carbonate, CO3, because there's 3 consonants. CO3, and 2 vowels, CO3, 2 minus. Clam is for chlorate. The answer is right here for you. But chlorate has 3 consonants, ClO3. And how many vowels? 1 vowel, so minus. Supper, sulfate, SO, 1, 2, 3, 4, SO4, 2 minus, because there's 2 vowels. And the last one, phosphate, P, 1, 2, 3, 4 consonants, PO4, and 3 vowels. 3 minus. So we have a mnemonic to help us to figure out the 8s, which are the most common. If you know nitrate is NO3 minus, you will know nitrite is 1 less oxygen, it will be NO2 minus. If you know that sulfate is SO4 2 minus, sulfite will be 1 less oxygen, which will be SO3 2 minus. So that's one thing to help you memorize about 80 to 90% of those polyatomic ions. In this case here, we just want to talk about the chlorates, which is one of the exceptions because there are 4 possibilities. We have chlorate, and again, if we lose 1 oxygen, it becomes chlorite. And we have to extend that idea. If we lose another oxygen, it becomes hypochlorite. And if we have 4 oxygens, it becomes perchlorate. In all these cases, we still have a charge of our species to be -1. So again, this will take time to be familiar with. Hopefully through practice, you will know this much more. So again, we have here the same methodology of crisscrossing. So here our NH4 is ammonium, which is on our list. We have NH4, which has a charge of plus, and bromine, which becomes bromide, has a charge of minus. And you crisscross and you get NH4Br. We do not include the ones again, just NH4Br. In the following example, we have aluminum and nitrate. Nitrate is NO3 minus. We take the aluminum plus 3, cross it down to the subscript for the NO3, and the nitrate, which is -1, it will come over to the 1 in the bottom for the left one. Aluminum subscript will be 1, and you get here AlNO3, which is aluminum nitrate. And then often I ask my class, how many aluminums, how many nitrogens, how many oxygens are in this compound? It would be 1 aluminum here, sorry, this would be small l, 3 nitrogens, and 9 oxygens. How many nitrates? It will be 3 nitrates, and how many aluminum nitrates? That would be 1 aluminum nitrate. There should be a 1 here. So we have 1 aluminum nitrate. So another example, here we have ammonium, which is the only positive polyatomic ion we use. Ammonium here is plus CO3 2 minus, which you remember is carbonate 2 minus. We crisscross and we get here this NH4 2 CO3. So I'm going to give you guys a try. You can pause the video and try each one. I'll do the first one. Name the following. It's going to be sodium for Na and nitrate for NO3. If it was NO2, it would be nitrite. But sodium nitrate. And for the bottom, let's look at the first one, Ca 2 plus for calcium, OH minus hydroxide, which is a polyatomic ion, we have a minus, and you crisscross to give CaOH2. You must put the bracket there, or else if you just wrote CaOH, the reader would think you have 2 hydrogens and only 1 oxygen. But in this case, we have 1 calcium, 2 oxygens, and 2 hydrogens. So we've been focusing on cations and anions coming together. Now we're going to talk about when 2 nonmetals come together, carbon dioxide, carbon monoxide. Those are some examples of 2 nonmetals. Again, nonmetals are located on the right side of the periodic table. So when you're naming the 2, the one on the left will keep its name. Let's look at carbon monoxide. Let's look at carbon dioxide, CO2. That's what we're familiar with. The first name, carbon, stays the same. And the second element, you don't say carbon dioxygen. The oxygen becomes ide, carbon dioxide. We also have to become familiar with our prefixes. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So we have to use these prefixes for nonmetals combining with nonmetals. So in this case, the first one, sulfur hexafluoride, hexa meaning 6, SF6, there's 6 of them. For the first name, on the left, we don't say monosulfur hexafluoride. Just like we don't say mono carbon dioxide, we just say carbon dioxide. The first name, if it has only one, we don't say mono. Okay, although we do say carbon monoxide if there's only one for the second element. So we go iodine pentafluoride, dinitrogen tetraoxide. Di means 2 nitrogens, tetra means 4. You can say tetroxide or tetraoxide. I'm okay with either one. So we name, so I can pause the video, we try the first one will be di phosphorus pentoxide, because there's 5 of them. And in our second example, the first one here, again, well, we'll do the tricky one here, dinitrogen, H2, monoxide, 1 oxygen, yes, dihydrogen monoxide, water. Water is the common name. And it's good to have a systematic way to name these because there's millions and millions of compounds that exist. So we need to find a systematic name. If we had common names for each one of those millions and millions of compounds, we would be a little bit confused. So you can say dihydrogen monoxide or the common name water, but 99.999% of the time we have to go through the systematic way of naming compounds. Here's a nice chart to summarize. We have here our ionic, metal and non-metal. If we have, for instance, this first column here forms only 1 positive ion, use the name of the element or ammonium. You can say, the example would be ammonium carbonate, ammonium hydroxide. If there is a Roman numeral, we have to know our Fe. For instance, iron is +2 or +3, copper is +1 or +2. And the nonmetal, it switches its name to ide for single negative ions, but when we have a polyatomic ion, that's when you have multiple atoms coming together that have a charge, carbonate, carbonite, nitrate, sulfate, phosphate, those are examples. We will have to remember those names. And what I just spoke about, when we have 2 nonmetals, the first nonmetal will keep its name, the second nonmetal will become ide. Carbon dioxide, dihydrogen monoxide. So if you've mastered each one of these categories, I put questions for you that come all together. So it's a mix of everything, so which is very similar to a test-like exam situation where you have just name the compound or write the name. As I said, one trick to do to check your answers is to, once you've written your answer, to cover the question and see if you can go backwards to get the original question. Our last topic is acids. Usually you add the word hydro in front, hydrochloric acid, and you add the ending acid. So in this case, this would be hydrobromic acid, hydroiodic acid. An acid is usually defined 99% of the time where the H is in front. If you have an H in front, usually designate an acid. And going the reverse, we have hydrochloric acid. Write the chemical name, it would be HCl. For our polyatomic ions, we convert chlorate. If we add a hydrogen in front, it becomes an acid. It becomes chloric acid. And the ite, in this case chlorite, will become hydrochlorous acid, or sorry, just chlorous acid and chloric acid for the chlorate. So I want you guys to try these four at the bottom. Just pause the video just to get familiar with how to name our acids or write the chemical compound. These are some common ones that we should be familiar with.